You already know how to use ice tables to determine the equilibrium composition and therefore the pH of solutions of acids and bases. And that's really the only skill you absolutely need for such calculations. But when we're dealing with a solution containing a mixture of an acid and its conjugate base, in other words, a buffer solution, there's a shortcut we can take. Starting with the expression for the acidity constant, we can easily show that the pH equals the pKa plus the log of the concentration of the conjugate base divided by the concentration of the conjugate acid. Protonation of weak bases and deprotonation of weak acids usually only proceeds to a very small extent. Thus, while these terms refer to the equilibrium concentrations of these species, it's often safe to assume that their equilibrium concentrations are closely approximated by their initial concentrations, meaning the concentration right after the acid and the base have been mixed together, but before any proton transfer begins. So we can replace the equilibrium concentrations with the initial concentrations, and the resulting approximation is called the Henderson-Hasselbalch equation. Note that this second term on the right goes to 0 when we have equal concentrations of the acid and its conjugate base. And so this equation tells us that under those conditions, the pH will equal the pKa. Here's a simple application of the Henderson-Hasselbalch equation, in which we calculate the pH of a buffer solution prepared by mixing acetic acid and its conjugate base, sodium acetate, at concentrations of 0.080 molar and 0.040 molar, respectively. Notice that we end up calculating a pH a little lower than the pKa, which is expected since we have an excess of the acid over its conjugate base. In this class, when you use the Henderson-Hasselbalch equation, I'll expect you to validate the approximation we made in deriving the equation by showing that the extent of proton transfer is low. To do this, you need to show that the hydronium ion concentration, which you can calculate from the pH, is less than 5% of the concentration of both the acid and the base. On the rare occasion when the approximation doesn't validate, you would need to repeat the calculation without using the Henderson-Hasselbalch equation by carrying out an ice calculation.